Hello everyone, this is the TI-84 guy. I'm back and I'm doing something a little bit different today. Almost all of the videos that I've put out have been in relation to the SAT, and today I thought I would do some problems from a practice ACT exam. So that's what I wanted to do today. I'm only going to look at 4 questions from this practice exam, but I wanted to show you that the programs that I've written, they work as well on the ACT as they do on the as the SAT. So, all right, so let me zoom in right now and make this a little larger for you to see. Now, this was taken from the practice test 59F. And this first question to me, I thought was, for a first question, I thought it was difficult. Generally, when you start the ACT, they start with pretty easy questions up till about 10, 12, somewhere in there, and then they start to get a little more difficult. And then by the time you get over to the number 50 or so, the questions are relatively more difficult. But I thought this number 1 for a starting question was actually challenging. It would be challenging for a lot of students. So let me read it, and then I'm going to show you how I would solve this. All right. It says, Carmen is playing with blocks. She arranges stacks of blocks so that each successive level of blocks has 1 fewer block than the level below it, and the top level has 1 block. Such a stack with 3 levels is shown below. Carmen wants to make such a stack with 12 levels. How many blocks would she use to build this stack? So what they're asking is, let me see if I can draw this. They're saying, okay, we start, level 1 has 1 block. Level 2 has 2 blocks for a total of 3. Level 3 has 3 blocks for a total of 6. So the first level, we have 1 block. The second level, we have a total of 3 blocks. And the third level, we had a total of 6 blocks. So what they want to know is for level 12, what's the total number of blocks we're going to need? Now, this, if you haven't recognized, is a arithmetic series because it's going up. Each time, each level is going up by 1, right? And what we want to do is we want to know what's the total for level 12. So that would be an arithmetic series. Now, I have written some programs for just this occasion, and I'm going to jump over and I'm going to show you what I'm going to do here. So I am going to share my calculator with you, TI84CE, and then I'm going to go to my programs. And the programs that I've written for sequences and series, it's called ASEQUERY. So I'm going to choose that, press enter. It doesn't have any variables in here. We're trying to find the total. So I'm going to say no. And then it says, oh, okay, what are you dealing with? Are you dealing with an arithmetic sequence? Is it an arithmetic series? Is it a geometric sequence, or is it a geometric series? In this case, we are dealing with the arithmetic series because we know that it's going up by 1, and we want to know the total for level 12. So I'm going to choose option 2 here. And then, so it says, what's the first term? The first term is level 1. And how many blocks do we have? We have 1 block. For level 2, what's the number of blocks that we have there? We're going to have 2 blocks in that particular one. So now it goes and it says, what do you want? Do you want the number of terms in this series, or do you want the sum? And we want the sum because we want to know the total number of blocks. So I'm going to choose option 1. And then it says, okay, where do we begin the series? We're beginning at level 1. So I'm going to put in 1. And then it's going to say, where do you want to end? I want to end at level 12. So I put 12 there, and it tells me that the total number of blocks that I'm going to need for 12 levels is going to be 78 blocks. So let me go back over to my test, and I would choose option B. Boom, that's it. Now, again, having students calculate an arithmetic series for the very first question of a exam, I think that's kind of challenging. So I'm not too sure about this test, but you know, it is what it is and you've got to be ready for it. So the program that I would use for this would be ASEQUERY. All right, now here's another question. I'm gonna jump around. I'm only gonna do 4 questions, so I'm gonna jump over to my next one. All right, this one is going to be 51. I wanna look at 51. So it says, a flight instructor charges $50 per lesson, plus an additional fee for the use of this plane. The charge for the use of the plane varies directly with the square root of the time the plane is used. So if a lesson plus 16 minutes of plane usage costs $90, what is the total amount charged for a lesson that lasts 36 minutes? So what we're trying to do is we're trying to figure out, okay, if we have to pay $50 up front, regardless of the amount of time that we fly. But then once we start flying, we pay based on the square root of the time. So in this case, so here's what it looks like. I'm gonna try to draw this. So here's the time and here's the charge, the cost. All right, or total charge, total cost. All right, so if it's 0 minutes, we've got to pay $50 for the lesson, right? If it's 16 minutes, we're going to pay, or the square root of 16 minutes, we're going to pay $90. And what they want to know is if it's 36 minutes, what are we going to pay here? All right, so now this is a linear function. So even though it has that square root part in there, this is still a linear function because it's varying directly. So it's proportional. So now here's what I'm going to do. I am going to go back to my calculator and I am going to share that. So now I'm going to go to program and I'm going to choose option 1 because this is going to be a linear function that we're going to use. Now, so what did they give us? They actually gave us 2 points. And here are the 2 points. We would go, okay, the first one was for 0 minutes, we have to pay the $50 service flying charge. And then for the square root, I'm going to put this in here, for the square root of 16 minutes, we paid $90, right? Now, boom. This is saying, what do you want me to solve for? We're trying to find the charge or the Y value, given that we know that the amount of time that we spent was 36 minutes. So here's what we're going to do. We're going to choose option 2. We're going to solve for Y. And it's asking us or it's prompting us for X. So what we're going to put in there is, again, we're going to put the square root of 36. And then we press enter. And it tells us that the Y value is $110. That's how much we would have to pay for 36 minutes. So I'm going to go back over to the test. And as you can see, that would be option D. All right. So it would be $110. This is a linear function. Use the ALINEAR program and you're good to go. Okay. So now, let me go to another question. Let me see, done with this, go over. All right, so now I want to look at question number 55. Now, basically, when you get to the 50s on the ACT, those questions are generally considered more difficult. The closer you get to 60, the more difficult generally they are, relatively speaking. So now, so we're looking at a number 55 question here. So let's see what we got here. It says, for some real number A, the graph of the line, I want to move this over a little bit. Sorry, I want to get this settled a little better. All right, so it says the graph of the line, y equals a plus the quantity a plus 1 times x plus 8 in the standard xy coordinate plane passes through the point 2, 6. What is the slope of this line? So we know that this is a linear function, and they want us to find the slope. So what did they give us? Well, they gave us 1 point, and they also gave us another point. It's embedded in that equation, but that's another point. The other point would be 0, 8, because that's the y-intercept. So we have 2 points here. So we're going to go back to the calculator. Let's go back. And what we're going to do here is we're going to press enter since we just used it, and we're going to use option 1 for 2 points. The 2 points are 0, 8, the y-intercept, and then the other point that the line goes through is 2, 6. Boom. Press enter. We want the equation. It tells us that the slope is a -1. The y-intercept is 8 as we expect, so the slope is a -1. This question is done. All we have to do is grid it in, and we are finished. It would be C. Slope is a -1. All right, now, I have one more question I want to do. This one is, it's not a program per se. It's just how strategically can you use your graphing calculator? I am a big proponent of not only using programs where they're convenient, but also using your calculator strategically to answer some questions. So let's look at this one, and then I want to show you how I would attack it. All right, so it says this is a number 56, so this is considered a relatively difficult question. All right, so it says the graph of the equation h equals a -at² plus bt plus c, which describes how the height h of a hit baseball changes over time, t, is shown below, right? So we've got this parabola. Basically, we've got a projectile, the baseball is being hit, and this is the path that it takes. It says, so the question is, if you alter only this equation c term, so we're just going to change this, which gives the height at the time 0. So basically that's the y-intercept. The alteration has an effect on which of the following. So they're saying, if we change the c term, what happens to the rest of the parabola? Does the h-intercept change? Yes, because we're going to be moving it. We're going to be changing c. Does the maximum value of h change? We'll see. Does the t-intercept change, or the x-intercept is basically what we're looking for. So here's how I would do this question. I would simply plug in for A. Let's say A is 2. Let's say B is 3. Let's say C is 7. And then I'm going to plug it into the calculator and graph it. And then I'm going to go back and I'm going to change C to 10, and I'm going to see how they compare. And then hopefully I'll be able to answer these questions. So now, so A is going to be 2, B is going to be 3, C is going to be 7, and then I'm going to change C to 10, and then I want to see how it affects the parabola. So let's go over, and we're going to go use the calculator again. This case is not a program. We're just going to go to y equals. That was from the last question. It gave us the linear equation that we were looking for. Now, I'm going to put in for A, it's got to be a -2x² plus 3x plus 7, right? And then I'm going to go down to y2, and I'm going to enter basically the identical equation, except that I am going to change the y-intercept. So I'm going to put 3x, and then for the y-intercept, I'm going to make it 10. And now let's graph it. So I go zoom, and I go 6. All right, so now as you look at this, you can, I'm going to make the window just a little bit larger. So I'm going to go down, I'm going to change the y max to like 15, and then I'm going to graph it again. All right, so here. So what we can see is that the y-intercepts, in fact, they do change. It moved from here to here. The maximum was here for the first one. Now it's been moved up to here. So that's changed. And you can see that the y-intercepts have also changed. Now I'm going to zoom in a little bit so we can kind of see that. Zoom in. I want to be over here so we can see what happens along the x-axis, but I think it's still clear. Press enter. All right, you can see that the x-intercepts also move. So this question is done. I go back and it says the h-intercept change? Yes. Did the maximum change? Yes. Did the t-intercept change? You bet. So that means the answer for this one is K. So this is supposed to be a difficult question, but if you strategically use your calculator, this problem is very simple. All right. So I wanted to switch it up a little bit. I wanted to show you that the programs that I've written are also valuable on the ACT as well as the SAT. If you'd like to get the ASEQUERY program or the ALINEAR program, all you have to do is subscribe to my channel, like the video, and please send me your email address. Make sure it's spelled properly, and I will get the programs to you as quickly as possible. If you have any questions or comments, you can put them down below. I would appreciate if you could, would subscribe, and also if you think these programs are helpful, tell some of your friends. I'm trying to reach as many students as possible. That's one of the reasons I want you guys to like the video, so that more likes get more views and I can help more students. So, all right, that's the TI-84 guy. Be safe. Bye.